Now we move on to something that's different. It is related to formulas, but now we're going to have math again. So what we call a formula mass is the average mass of an individual molecule or formula. So this would be given in atomic mass units because we're looking at a particle, not a whole bunch of them. It's also called a molecular mass or a molecular weight, the weight of a molecule, the mass of a formula unit. And it's not hard to calculate. We just look at what elements are in there, how much do they weigh, those numbers are on the periodic table, how many atoms of each thing are there. So the number of atoms of the first element, and then you multiply by what the atomic mass is. And then you add the number of atoms of the second element times its mass. And you just keep going if there's more than two. So calculate the formula mass of calcium nitrate. So we're also going to practice our nomenclature here. What kind of a compound is calcium nitrate? It's ionic, because calcium is a metal, because it's on the left side of the periodic table. So we need the formula so we can calculate the formula mass. So for ionic compounds, we're going to write the formula for the ions. What charge does calcium ion have? +2 because it's in group 2. And nitrate is NO, NO3 with a -1. So I've got +2 and -1. I need 2 of these guys, right? So as a group, those guys would be neutral. So the formula here is CaNO3 2. So to calculate the formula mass, we need the formula. And there's one calcium in here, 40.078. That's the mass of one calcium atom. And then how many nitrogens are there? There's 2. If we look at this formula, this 2 multiplies everything inside. We also have it drawn out here so we can see there's 2 nitrogens. So 2 nitrogens times, I'm just going to use the 4 sig fig ones, times 14.01 atomic mass units. And how many oxygens? There's 6 of them. And their mass is 16.00 atomic mass units. So we just get out our calculators and type it in. And you can just type it in as it's written, and your calculator will understand. They've gotten a lot smarter. So this is showing 164.098. The unit would be atomic mass units. What about sig figs? Well, that's a great question. You can argue that different ways. My feeling is we should treat this as addition. We're adding this 6 times, right? So if 2 decimal places is the fewest decimal places of all my atomic mass units, then this should end with 2 decimal places. If you're using this number in another calculation, use it unrounded. That would be better. Any questions? That was formula mass. Molar mass. This is the mass of 1 mole of the compound. We've talked about molar masses of elements. It's a mass of 1 mole of atoms. So this is the mass of 1 mole of molecules or formula units. It's going to be the same number as the formula mass. The unit is different. It's grams instead of atomic mass units. And I'm not going to try to trick you with that one. What is the molar mass of ammonia? What do we need first? The formula of ammonia. That's something you need to memorize. Anybody know? NH3. Ammonium is NH4 plus. This is ammonia. It's just losing that hydrogen ion. So now that we have the formula, here what we're thinking of, I usually write these actually without units, which is kind of sloppy, but this is 1 mole of nitrogen times 14.01 grams per mole of nitrogen plus 3 moles of hydrogen times 1.008 grams per mole of hydrogen. So the moles cancel out. The calculator says 17.034. And that would have 2 decimal places. This is the mass in grams of 1 mole of the substance. So we can say that 1 mole of ammonia is equal to 17.03 grams. And we'll find out that that's a really useful conversion factor. Any questions? Like with all the units and stuff? No. I'm just doing that this one time so that you see that there are units and they do work out. But this is such a common calculation. We just write out the numbers, type them in, and slap a gram on at the end. Yeah. No, that's very tedious. I'm not into tedious. Sometimes it can't be avoided, but. So, just like we used the molar mass of an element to count atoms, we can use molar mass of a compound to count molecules by weighing them. So, this is a dimensional analysis problem, and the path here is you start with a mass of this compound, we'll call it A. You convert to moles using the molar mass, and usually they're not going to give that to you. You'll have to calculate it. And then you convert from moles of A to molecules of A using Avogadro's number, same way we did for atoms. So the word molecules is a lot longer to write than atoms, and the molar mass may involve some calculating instead of just picking a number off the periodic table, but it's the same process. Find the number of ibuprofen molecules in a tablet containing 200.0 milligrams of ibuprofen. The formula is given because nobody remembers that. C13H18O2. Well, what do they give us? What number and unit? 200 milligrams. That's the wrong highlighter. Let's try that one. 200 milligrams, right? And what are they asking for? Number of molecules. So we're going to be starting with 200.0 milligrams, and we're going to go to molecules. Do you remember this show, Malcolm in the Middle? Yeah. moles in the middle. Most of these calculations are going to have moles in the middle. That's the unit that you need to get from one end to the other. So, milligrams, well, we could convert that to grams, right? And we know that molecules, a mole is a certain number of molecules, right? And so there's our mole in the middle. And the molar mass gets us from grams to moles. So this is the same path we talked about on the previous slide, but we threw a little curve into it by giving you the mass in milligrams instead of grams. So there's one more step. So we have 3 arrows. We're going to have 3 conversion factors, 3 fractions. So milligrams to grams to moles to molecules, milligrams to grams to moles. And this is where I wish they had an abbreviation for molecules. Molecules. Put the previous unit underneath so they're going to cancel out. Milligrams to grams to moles to molecules. Milligrams to grams to moles to molecules. I need milligrams to go away, so I'm going to divide by that. I need grams to go away, divide by grams. I need moles to go away, divide by moles. I'm left with molecules, which is what I was trying to find. Where do I get the numbers? Well, some of them are kind of hiding on the periodic table, right? And then we need to know what this metric prefix means, and we need the molar mass of ibuprofen. So I'm going to start with what seem like the easier ones to me. The prefix milli stands for 10 to the what? 10 to the negative 3. So the prefix is down here. I write 10 to the negative 3 on the opposite side, because 10 to the minus 3 and this lowercase m are just different ways of writing exactly the same thing. So you don't want to put them together. One on one side, one on the other. That's 1 times 10 to the minus 3, and that's 1 milligram. Then over here, mole is the chemist's dozen, and instead of 12 molecules, it's that crazy number of molecules, 6.022 times 10 to the 23rd. And this is just like the worst, because you've got this really long number and this really long unit. There's got to be a better way. I don't know what is. Last night in lab, one of my students asked if I knew any ways to make significant figures fun. Oh, we laughed and laughed and laughed. Yeah, it's like this. There's no better way. Molar mass. So they gave us the formula. Now, I highly recommend writing a little bit of stuff down when you calculate the formula. Obviously, you could do this without writing anything down. Just do it on your calculator. But let's write it down. Question? That's a good question. Could molecules be written as atoms? Technically, molecules are not atoms, and so that could get confusing. It's certainly tempting because atoms is a shorter word, right? See, my thought is mole should just be M-O-L-E. It's not that long. And M-O-L should be molecules, but it's not that way. So it's just this stupid long word. So this is what I recommend writing down. So there are 13 carbons, and then we're going to put the mass of carbon plus 18 hydrogens times the mass of hydrogen plus 2 oxygens times the mass of oxygen. if you write it out that way, it allows you to run it through your calculator twice to make sure that you did it right. And if there's a mistake, you can go back and see what happened. You know, sometimes people write the mass of calcium instead of carbon. That'll mess things up. 13 times 12.01 plus 18 times 1.008 plus 2 times 16. I'm getting 206.274. And that's grams. Any questions? This is one of those very important skills. Dimensional analysis, being able to convert between grams and milligrams, really, really important. Calculating molar masses, really, really important. Writing the formulas of hydrates, not so much. Not so much. I wasn't done, was I? I'm like, oh, where did all my work go? Please. Oh, phew. So yeah, I got this number, and then I got all excited and thought I was done. That's why I put the answer up there, because occasionally this happens. So it's this many grams in 1 mole. So we got to stick it in here. Okay. We have more calculating to do. 200 times 1 EE negative 3 divided by 206.274 times 6.022 EE23. So how many sig figs should this answer have? It'll be 4, because this one's 4, and this one's 5, and that one's 4. 5.83883 times 10 to the 20th. So 5.839 times 10 to the 20th molecules. Any questions?